Alright, this is video I21, and last time I asked you to go ahead and try to do this problem. Terrible problem. Okay, and so I've given you a quadratic in vertex form. The vertex would be 1, 1. You can graph this however you want. And we have to graph it over an interval from 0 to 3. So 1, 2, 3, 1, and here I have my vertex. Okay, it is opening up, and so it's going to look something like this. And note I'm not really caring too much about the y values. Okay, it's unimportant for our problem. Okay, what we're told to do is we want to first find a Riemann sum by breaking this up into n rectangles. Okay, and in each rectangle we'll use the right hand endpoint. And I hope you can see, since I have a decreasing part here, that's supposed to look like the lowest point, and an increasing part here, okay, this isn't a left or a right hand sum. Okay, I'm sorry, this isn't an upper sum or a lower sum. We're just using the right hand to decide. On this part, right here, okay, the right hand sum would give us a lower sum, since it's decreasing. Okay, but over on here, the right-hand sum is giving us the higher point in each interval. All right, but it doesn't matter because of how we're going to end this problem. Okay, so let's go ahead and review what we did last time in finding a Riemann sum. Okay, so this is x equals 3. I've broke it into n rectangles again. Okay, the base of each rectangle, hopefully you can see down low on the page like that, since there are n of these, each one would have to be 3 divided by n long, each interval. What that means then also is that this x value is 3 over n, this x value, another 3 over n, so 6 over n, then 9 over n, all the way out to here. And this would have to be 3n over n, which does equal 3. Okay, and so we can start to develop that Riemann sum. Okay, the area, which would give me the approximate area I have drawn here. So the area is approximately, okay, this rectangle's area plus this one and so forth. Each base is 3 over n, so I'm going to write that on the end and know that I could distribute it to each of these heights. Each height, the first height is the y value I would get by plugging in that x value. And then the next height would be the y value here for this x, and so forth. And typically you just have to write enough of these until you see a pattern. Clearly our pattern is 3, 6, 9, and so forth, all the way to the last height, 3n over n. All of these y's times the base length right here, which is 3 over n. And so kind of a generic looking Riemann sum would be the sum. Now we're going to go from k equals 1 to n, since there are n rectangles. And then I have to find some formula so that my first term would be f of 3 over n. My second term, f of 6 over n. And clearly, if I multiply this k value by 3, my first term, when I plug the 1 in, I get a 3 here. My second one, when I plug a 2 in, I get the 6, and so forth. And so that does work. I can't forget that I have the 3 over n. Okay, but we don't have to leave it like this. This would just be a generic one for an interval of 3. We know f of x, and so my area is approximately the sum from k equals 1 to n of, and now this is your x value, so we have 3k over n minus 1 squared plus 1 all times the 3 over n. And so this would be the answer to the first part of your question. Find a formula for a Riemann sum. Okay, and then to continue with this, okay, we want to try to simplify this using what we know about summations, and then find the limit of this sum. Okay, and this looks challenging, but we have all sorts of time, don't we? Okay, and so the 3 over n is simply a constant. Okay, I'll have multiple terms in here. I would want to square this in here as well. Okay, and I'll probably gloss over quite a bit of the algebra. As a matter of fact, I really don't want to do too much of it. Let's do this. The area is approximate. I'm going to pull that 3 over n out in front. And I have the summation from k equals 1 to n. Okay, now squaring the 3k over n minus 1, you can do that fairly quickly. And then adding a 1 to it, okay, note that I pulled the 3 over n, the base length, out in front. Okay, and I want you to remember the n is simply a constant. Here we have a constant times a quadratic sum. Here it's a linear sum. Here is a constant sum. And so I'm going to let you do that work. And we would discover that our area is approximately, where did I write this down? Let's see, I have 9 halves times 2 plus 3 over n plus 1 over n squared minus 9 plus 9 over n plus 6. Okay, but to answer the last part, okay, we want to find the limit of this. And note that I changed to equals, because I'm going to take I want my number of rectangles to approach infinity. Okay, and so I get the same thing I just started with there. And notice the way in which I wrote this allows us to quickly evaluate this limit, because those terms will all approach 0. And here I have 9 minus 9 plus 6, so the exact area is 6. And now I think you guys can do 1 through 11 on the review. This is kind of a tough part of the review. I think let me get the review out really quickly. I hope I can find it quickly enough. I think the wording on some of the problems may be a little odd. Let me look. Yeah, if they say f of ck, this is just the x value you're using in the kth interval. And let me see. I think the rest of it you can probably read. So good luck. Why don't you take an extra day to do all those problems? Good luck with that, guys.